Let's take a look at this next problem. Again, we've got logs on two different sides of the equation, so let's add the log on the right to both sides. This will give us log base 2 of x plus log base 2 of x minus 6 equals 4. And then we have two logs being added together, so we can multiply the arguments together. Log base 2 of x squared minus 6x is equal to that 4. And we can convert it from a logarithmic to an exponential equation, and we will have 2 to the 4th is equal to x squared minus 6x. That is a quadratic equation. We want to set it to equal to 0 by subtracting that 16 on both sides. So 0 is equal to x squared minus 6x minus 16. That is going to factor easily into x minus 8 and x plus 2. And we have x is equal to 8 or negative 2. Now let's check these values. Back in the original problem, log base 2 of 8 looks good. 8 minus 6 is 2. Looks good there. Now negative 2, we have a problem. We cannot have a log of a negative. So this negative 2 is going to have to get crossed off, and our solution set is going to contain only 8 for this problem. Okay, looking at this next equation, we see a plus sign between the two natural logs, and we know that the sum of two logs is the log of their products. So we can combine this and write this as the natural log of multiplying x times x minus 3, we get x squared minus 3x equals what's on the right side already, the natural log of 5x minus 7. And since we have natural log of something equals natural log of something, log equals log, we can essentially anti-log each side, removing the logs, giving us x squared minus 3x is equal to 5x minus 7. And then we see we have a quadratic equation, which we will set equal to 0, subtracting 5x off of each side and adding 7 to each side. This gives us x squared minus 8x plus 7 is equal to 0. And this factors easily into x minus 7 times x minus 1 equals 0. And we get x is equal to 7 or x is equal to 1. Now we need to check each of these answers, and the main thing we want to check is to make sure that we don't get a negative or a 0 inside of a logarithm. Well, both of these are positive numbers, so we're already pretty safe. But notice when you substitute 1 into this second natural logarithm up in the original problem, you get the natural log of 1 minus 3. That's the natural log of negative 2, which will not work, and we need to cross that answer off. Now, natural log of 7, 7 minus 3 is 4, we're safe there. 5 times 7 minus 7, that's positive, all's well there. So our solo answer to this problem, our solution set, is the number 7. And let's do one more problem here with the compound interest problem. They're giving us the formula right there. 10,000 is being invested, interest rate of 2.5%, and we want to earn 2,000, meaning we're going to end up with 12,000 for A when 10,000 is invested. Okay, be careful with that. We're going to have 1 plus interest rate 0.025 over monthly, which tells us we're dividing by 12. We're asking how long, so we're solving for time, so nt will be 12 for n. T is what we're solving for. Our t is up in that exponent position, so we're going to have to use logarithms. But before we do that, let's begin by dividing off this 10,000 on each side. That will give us, on the left, 1.2, and on the right, this parentheses, 1 plus 0.025 over 12, all to the 12t power. The way to get that t out of the exponent position is to take the log or the natural log of each side. We will have the log of 1.2 is equal to the 12t that comes down times the log of what is in the parentheses there. No change inside. We look at where we're at. We have the t on the right. We want the 12 to be divided off as well as the logarithm to be divided off. And that means the left side will become the log of 1.2 divided by 12 times the log of 1 plus 0.025 over 12, close parentheses. That will equal t. That will be our exact value. Now you've got to be able to enter this into a calculator, and you've got to be careful here. I would recommend that you put extra parentheses around the denominator so that you're not just dividing by 12 and then putting that log up on the top with multiplication. Just be careful. The answer here is going to be t is approximately 7.3004 years. But the problem says to the nearest month, so this would be t is approximately 7 years, and 0.3 of a year is about 4 months. So comma 4 months.